And okay, so for the first question, they want me to find the summation of k minus 4 from k equals to 1 to k equals to 3, which means what I have to plug in values for k from 1 and then 2 and then for 3. So if I plug in k equals to 1, then I have got I get 1 minus 4, and then which is equals to minus 3. For 2, I get 2 minus 2, which is minus 2. For 3, I get 3 minus 4, which is minus 1. So the sum will be the addition of all of them. So since they are all negative, 3 plus 2 plus 1 is 6, but negative 6 because they are all negative. So this will be our final answer. There we go. All right, so expand the expression 3p plus 4q to the whole cube using the binomial theorem. For your convenience, here is the Pascal's triangle with its first few rows filled out. Okay, so since we have a cubed here to the power 3, we only need to fill this triangle to row 3, up to row 3, which is 1. Both sides get 1, and the plus addition of these two, 2 plus 1, which is 3, and 2 plus 1, which is 3. So the first term, will be 3p to the whole cube plus the coefficient which we have found here, which is 3, times 3p whole square into the last term from here, which is 4q. And there we go. That is enough for this term. And I don't have space here, so I use this one. So plus, again, we have the coefficient of 3 multiplied by 3p. This time we don't have any square, multiplied by 4q whole square. And for the last term, we have 4q a whole cubed. So the final answer will be 3 cubed, which is 27, p cubed plus 3 into 3 square. So 3 square is 9. And so we multiply 9 with 3, which is 27. And we multiply 27 with 4. So 4 sevens are 28, 4 twos are 8, and plus 2, which is 10. So we have 108 p squared and q. Okay, that is for the first two terms. Then for the last two terms, we have 3 into 3, 9. 9 into 4 square. 4 square is 16. So 16 times 9. 6 9 is 54. 9 1 is 9. 9 1 times 9 plus 5, that is 14. So 144. 144. And p q squared, I think. And then 4 cubed, which is 4 into 4 into 4, so which is 16 into 4, and 6 fours are 24, 4 ones are 4, and then plus 2, which is 64. So 64 q cubed. So I think that is the final answer. If my calculations are okay, let me just recheck. So we know that 6 9 is 54, 9 ones are 9, plus 5 is 14. So I think this is the final answer, which is 27p cubed. So let me just plug that here, 27p cubed plus it was 108p squared, 108p squared, q plus 144p. So q plus 144p q squared plus we have the last term, which is 64q cubed. So 64q cubed. That is the final answer, I think. And there we go. So for this one, we have the geometric sequence AI. A sub I is defined by the formula. A1, they have given us the first term, which is -4. And in order to get the next term, as we can see, AI, we have to insert the previous term. We have to multiply the previous term with 2, which means A2 will be -8. That is 4 times 2. So each time we're multiplying by 2. That's why R, or the common ratio for this geometric sequence, will be equal to 2. They want us to find the sum of the first 50 terms, that is S sub 50. So S sub 50, we know the formula for Sn, which is A multiplied, bracket 1 minus R, the common ratio to the power nth term. Oops, sorry for that. And divided by 1 minus R. So we know the first term is -4. So -4 times 1 minus R, which we have found to be 2 to the power n, which is 50. And then divided by 1 minus the common ratio, which is 2. So if we calculate this, we should be able to find the sum of the first 50 terms, so which is equal to, so it will be equal to -4, and then plus we have 4 into 2 to the power 50 divided by -1, which is equal to -4 plus 4 can be written as 2 squared into 2 squared into 2 to the power 50 divided by -1. And I think I can solve this by going on and using manual calculation, but I think plugging this into the calculator should give me the correct answer even faster. So -4, we have plus 2 squared plus 2 squared into 2 to the power 50 into 2 to the power 50 and divided by -1, so which means bracket, because we are dividing -1 to the entire thing, divided by -1. So we can see we get an answer -4.5 times 10 to the power 15. So that matches with choice B. So choice B should be our answer. There we go. Okay, for this one, find the sum of 5k minus 87 from k equals to 1 to up until 40. So if we plug in k equals to 1, we get 5 minus 87. So that will be -82, 83, 84, 85, 86, 87. Yep. So that is the first term. And we can find the last term as well, L, when we plug in the value for 40. We plug in the value of 40 in K. So 5 times 40 negative 87, so which will be equal to 200 negative 87, and that will be equal to 113, I guess. 5 4 is 20 plus 0, negative 87, so 390. Yeah, I think last term will be 113. And we know that the formula for Sn is first term plus last term divided by 2 multiplied by n, number of terms. So we know that n will equal to 40 because from k equals to 1 to 40 we have got 40 terms. And we know the first term, we know the last term, so we can just plug them in here. Negative 82 plus 113 divided by 2 multiplied by n, which is 40. So 113 minus 82 will be 1, and then this becomes 11. So 9, 10, 11, 3, and this becomes 0. So 31. So we have got 31 divided by 2 into 40, and I can cancel out 2 with 40 by replacing with 20. So we only need to find 31 into 20, which is, we have a 0 here, and for this bracket here, I mean for this portion here, 2 ones are 2, 3 twos are 6, this will be 620. So I think 620 will be our final answer. There you go. Moving on. So to this question, they are asking a new shopping mall is gaining in popularity every day since it opened. The number of shoppers is 5% more than the number of shoppers the day before. It is getting increased 5% every day. The total number of shoppers over the first 10 days is 1258. How many shoppers were at the mall on the first day? So, which means that we know that 5% is 5 divided by 100, which is equals to 0.05. So this is our R, the common ratio. So if we have 5% more, then this is the increase amount. So each term will be the 0.05 plus 1, because that is the previous uh, the previous one is there. So R will be 1.015. I mean, the next term will be 1.05 times the previous term. Okay, so they've given us the total number of shoppers over the first 10 days is 1258. So the total number of shoppers, which means S sub 10, they have given us, it is 1258. They're asking us to find A, the first term. How many shoppers were at the mall on the first day? We have to round my answer, final answer, to the nearest integer. So we know the formula for Sn, which is equal to A times 1 minus R to the power n over 1 minus R. So we know that S10 will equal to this 1258. So let me erase that. So I can plug this in here. 1258 will equal to A, which is what we want to find, and then 1 minus R, which is 1.05. 1.05, and to the power n, which is 10, divided by 1 minus 1.05, And there we go. We just have to calculate a from here. So which will be 1258 into 1 minus 1.05, which is just 0.05, and this number divided by 1 minus 1.05 to the power 10 will be our a. So 1258 1258 1258. So I put a bracket here. Oops. But so bracket, first of all, bracket 1258 multiplied by 0.05 bracket close. Now this is going to be divided by, I put another bracket, and this will be 1 minus 1.05 to the power 10. So let me see what they give us, which is negative 100, 1258 into 1 minus 1 point. Okay, there will be a minus sign here. So 1 minus 1.05 is minus 0.05. So there will be a minus here. So which means that everything should be fine except for the minus sign. So which means the answer is positive 100, and round your answer to the nearest integer. So I think the answer will be equal to 100. And there we go. So we have to find the summation of 2k minus 1 from k equals to 0 to k equals to 1. So plug in k equals to 0 and plug in k equals to 1, add them up. There we go. So if we plug 0, we have got minus 1, and if we plug 1, we get 2 into 1, 2 minus 1. So minus 1 and minus 1 is minus 2, and plus 2 is, I think the answer is 0. They cancel out. Expand the expression using the binomial theorem. For your convenience, here is the Pascal's triangle with the first few rows filled out. So since we need to find up until to the power 4, we will continue up until row 4. So 1, 1, 3, 3. This is 1, 1, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4. This is 6. Sorry for my handwriting. So 6. And the first term will be 2 times z to the power 4 and plus. Okay, so since we have got a minus, what we will do here, a little trick, we will do 2z plus, and we will take negative 3k in bracket, and we include the minus with the b term, with the second term, negative 3k, and there we go, to the power 4. So 2z to the power 4 plus, we have the coefficient, which is 4 into 2z whole cube into, we have ones of that, negative 3k, plus the next coefficient, which is 6, into 2z squared into negative 3k squared, plus we have got 4 into 2z one time, negative 3k cubed. plus we have got last term negative 3k to the power 4. So we just have to calculate that for finding our answer. So 2 to the power 4, 2 to the power 4 is 16. So that means this will be 16 z to the power 4. So 16 z to the power 4, and then you have got 4 into 2 cubed, 4 into 2 cubed, what's wrong with this? 4 into 2 cubed, and multiplied by, so multiplied by negative 3, negative 3. 4 into 2 cubed multiplied by negative 3, so we get negative 96. So negative 96, and negative 96 z cubed into k. So z cubed into k. That is enough for the second term. And for the next term, we have got 6 into 2 square, which is 4. 6 into 2 square, which is 4. And then we have got negative 3 cubed, that is positive 9. So positive 9, that is equal to 216. So positive 216. And we have got z squared k squared. So z squared k squared. For the next term, we have got 4 into 2, which is 8, into, we have got negative 3 to the power 3. So it will be 8, 4 to the 8, into negative 3 to the power 3. 4 to the 8 into negative 3 to the power 3, that is equal to negative 216. So negative 216, and we have got z1 and k to the power 3. So z and k to the power 3. Okay, and for the last term, we have got negative 3 to the power 4, which is equal to positive 3 to the power 4, and that gives us 81 k to the power 4. So plus 81 k to the power 4. That should be our final answer. And there we go. So a monkey is swinging from a tree. So there's this tree, and we have a monkey here. So on the first swing, she passes through an arc whose length is 24. With each swing, she travels along an arc that is half as long as the arc of the previous swing. So the next, so I can see there is some sort of geometric progression here. So the next term will be 12. Half of 24 is 12. So each term you are basically multiplying with half, or 1/2. So with each swing, she travels along an arc that is half as long as the arc of the previous swing, which expression gives the total length the monkey swings in her first n swings. So here they're asking us to find Sn, which is equal to A, first term is 24, 1 minus r, which is 0.5 to the power n, and that is over to 1 minus 0.5, which is equals to negative 0.5. So let's see which answer choice has our calculation here. Definitely 1 and A and B does not, because 1.5 is not. 0.5, yeah, it does. So the only difference is negative 0.5 and 0.5 between C and D, which you will see because it will be negative 0.5, because 1 minus 0.5 is negative 0.5. 24 into 1 minus r, into we have got 1 minus 0.5, 1 minus r. So r, okay, oh sorry, 1 minus blunder, 1 minus 0.5 equals 0.5, because we take the sign of the greater number, so that will be D. Anyway, so an arithmetic sequence is defined as follows. Find the sum of the first 26 terms in the sequence. So they're talking about S26, S sub 26 to be specific. So S sub 26, we know the first term is 49 there, and this is an arithmetic series sequence. So this is D, the common difference, which is negative 3. So the formula for Sn, the summation of terms in arithmetic series, is the first term, the last term, divided by 2 multiplied by n. So the sum of the first 26 terms, we don't know the last term, so we can replace L with, a plus n minus 1 d, which is the nth term. We can replace that here with L. So a plus a will be 2a plus n minus 1 times d divided by 2 into n. So the sum of the first 26 terms will be just S sub 26, which is equals to 2 times a. So we know a is 49 plus n minus 1. We're trying to find 26, so that will be 25. 25 times d, which is negative 3, over 2 into n, which is 26. This should be our answer. So 2 into 49. So I think Desmos is much more it's really quicker and convenient for me. So so we have got 2 into 49 and plus this is 25. So 25 into negative 3, and upon 2 times 26 upon 2 times 26, that gives us a value of 299. So I think the answer will be equal to 299. There we go. Last question. Find the sum of the geometric series 1 minus 0.99 and plus 0.9. Okay. So first of all, we know the first term, which is 1, so that equals a, and the r, the common ratio, will be the second term, negative 0.99 over the first term, which is 1. So our r is just negative 0.99. And I can see that we go up until to the power of 79. So in the first term we don't have any of 0.99 term. So in the second term we have got a power of 1, third term power of 2, so which means that we've got 80 terms in total. So n equals 80. Now we just find S sub 80. So let me use this slide. S sub 80, which is equals to the first term. The first term is 1 times 1 minus the common ratio, which is negative 0.99 to the power 80, because that is the 80th term. over 1 minus the common ratio, which is negative 0.99. That should be our answer. Oops, I don't know what's wrong with this. They are not allowing me to write 9 here. So I just write 9 here. Anyway, so oops. So there we go. This is 1 minus 0.99. So this will be our sum. So if I calculate that, I get 1, this is the first term, into 1 minus and then bracket minus 0.99 to the power 80. So that raised to 80, and the bracket closed, of course, and then 1 minus, so again minus, so we can just write plus 0.99. So I can see it is 0.2776. That means 0.28. So B should be our answer. And there we go.